we're going to present our work on metamorphic robustness testing, which exposes some very interesting hidden defects in citation statistics and journal impact factors. This is a journal first presentation for an article published in IEEE Transactions on Software Engineering. We've been asked to compress our 20-page paper into 6 minutes, so we can only concentrate on some of the more interesting aspects. Let's provide some background first. A test oracle is the mechanism to check whether the execution result of the software agrees with the expected outcome. We say that there is a test oracle problem if the oracle is not available in real life. Let us give an example in Google search. Suppose we want to find hotels near JP Morgan. We do a Google search and obtain 5 million results. This is an oracle problem in big data because we're not so sure whether 5 million is right or wrong. In metamorphic testing, we alleviate the test oracle problem by verifying the consistency between multiple executions rather than single execution. This is known as metamorphic relation. In Google search, for example, we would like to apply a metamorphic relation such that if we refine the keyword search, we should give fewer results. So we refine our search to the full name of JP Morgan Chase. We obtain 6 million entries, which in fact is 1 million more than the 5 million that we have just obtained. This indicates that there is a failure in the Google search engine. We're going to extend the metamorphic testing to robustness testing. We want to verify whether a system can deal with erroneous inputs. For example, can Web of Science citation index handle citations with a typo in a hyphen inside the paper title? Again, we have a test oracle problem because of the big data. So we introduce the concept of metamorphic robustness testing. We define metamorphic relations to test the consistency between multiple retrievals in citation index systems. An example of metamorphic relation is the given large set of publications without systematic differences, their mean citation counts should also have very little systematic differences. Indeed, if we have various sets of publications with different number of hyphens in their paper titles, their mean citation per paper should be very, very similar. In real life, however, we find from Web of Science that the mean citations per paper actually decreases when we have more and more hyphens in the paper titles. Thus, we have a robustness failure in the indexing system. We have further findings. We have discovered further failures in citation counts and impact factors at the article, journal, and subject levels. Unfortunately, we are limited by 6 minutes of our presentation time, so we have to ask you please refer to our original paper. In conclusion, our result questions the belief that citation counts and journal impact factors are reliable quality measures. Unfortunately, these factors do affect our promotion and tenure, but these same factors are distorted simply by the presence of hyphens in paper titles. Our so-called bizarre new finding was reported in numerous international media such as Nature, Communications of the ACM, Psychology Today, The Australian, Science Alert, and Wikipedia. On the other hand, not everybody was amused. The original vendor, Web of Science, issued a strongly worded rebuttal. They stated that hyphens in article titles have no impact on citation counts. They emphasized that the methodology has been tried and tested over many years. We would like to offer our final observation. This exactly demonstrates the significance of our new work in discovering robustness problems that were hidden from previous testing. Your comments are most welcome. Thank you.